Sorry, I forgot to do the second example that I wanted to do. Let's do one where we have some negative powers and a restriction, because that can be a little trickier. So first of all, I'm going to rewrite this with negative powers. 2x minus 3 is now to the power of -1. So what I'm going to do is differentiate this like normal. So dy dx. So I'm going to bring my power down, which makes this -5. I've got 2x minus 3, which becomes -2. And I need to use the chain rule. So I now need to multiply by the derivative of the brackets. So that now gives me -10. And then we still have a 2x minus 3 to the power of -2. So now I'm going to rearrange this so I have no negative powers. So this now goes down here. 2x minus 3 squared. Now, the reason they've given us this restriction here is so that the denominator has certain restrictions. So I'm going to change colors. So if we're now going to use this, we're going to think about what that means for this particular thing, right? I mean, that's really just solving that bracket for us. So if I've got 2x minus 3, I'm just sort of going to show you. If that says it's greater than 0, then 2x is greater than 3, which means x is greater than 3 on 2, right? Which is the restriction they gave us. So it's just telling us what to do with this. So what that means is this value, the value of the denominator, is always going to be positive, right? Because the number has to be greater than this. And it also doesn't really matter because we're squaring it anyway. But what that means is that we have -10 divided by something, and it's irrelevant what this is. I mean, it's not allowed to be 0, which is sort of why this restriction exists, because we don't want to divide by 0. We can't do that. But if I say that this value, the value of the derivative, is always going to be greater than 0 because we have a negative number and we're always dividing by a positive. So regardless of what it is, it's always bigger than 0. That means I'm going to get rid of this positive thing that I've just drawn because that's not helpful, because the value of the function is always negative. There is no value of x you can put in, given our restrictions, or frankly not, that would make the derivative ever be negative, which means it's always going to be, I think I just said the wrong thing. The value of this is never going to be positive because you've got a negative dividing a positive, which means the answer is always going to be negative, which means this function is always decreasing. All right, I hope that was helpful.